Today we're going to study interfaces. Go directly to the code. Create a new project. Call it interface. Create the class main and an entry point. Now let's create an abstract class called animal. This class will have only one abstract method, eat, and no fields. This method will not return any values. We will need 4 kinds of animals. The dog, the cat, the fish, and the bird. All of them inherit from the class animal. We remember that there is one abstract method which is to be overridden. To do it quickly, press Ctrl+I. Select the method we need and click OK. Let this method print out what a given animal eats. Here we will have a bone. We will do the same with every animal. Let's inherit from the animal and implement the method. The cat eats Whiskas. The fish eats fish feed. The bird eats poultry feed. Now in the method main, let's create one kind of each animal. So the task is as follows. We want to use a loop and make every animal eat. How is this done? We can create an array list and add all the animals into it. But which type will we specify in the angular brackets? If we specify dog, we will easily add the dog there. Let's give it a try. Call this animals. Write an assign symbol, new array list. Add the dog to the animals. It was easy. Let's add the cat there too. And here is a problem. We cannot add a cat to an array of dogs. All these animals inherit from the class animal. We could write animal in the angular brackets. Indeed, the error is gone now. Let's add the animals. Animal add the fish. Everything's fine. The same for the bird. There are no errors because these animals are subclasses of the animal. Let's now create a for each loop which will make every animal eat. Write for. The type is animal. This is an array of animals, so we will call the variable animal too. And now we will call the method eat for our animal. Run the program. You can see that every animal eats what it is given: a bone, some Whiskas, fish feed, and poultry feed. This advantage of OOP is called polymorphism, one interface with several implementations. It means that from all the variables we called one and the same method, and it behaved differently depending on which animal it was called from. We can cast each of the derived classes to their superclass. This is called upcasting. It means that we can create an animal. Since it's an abstract class, we cannot create an object of this type, but we can create, for instance, a dog. Write new dog. You may as well write new cat, and the cat is cast to the superclass automatically. Now let's teach our dog how to run. Go to the class dog and create a method. Public void run. Let's display the line. The dog is running. Get back to the class main. Create a new dog and call the method run from the dog. We can see that our dog is running. Now let's cast our dog to the animal type. Write animal. Animal, assign symbol, dog1. It means we have taken an already created dog and cast it to its superclass, the animal type. In this case, the variable animal refers to the object dog. Now let's call the method run from our animal. Write animal.run. We can see an error because the class animal does not contain this method. It only exists in the class dog. It's important to understand the principle. When we are upcasting, casting to the superclass in the object, we can only use those methods which exist in the superclass. There is the method eat in the superclass, so using eat is not a problem. But the superclass has no method run, so we cannot call it. We can cast our dog back to the dog type. Write dog1, assign symbol animal. In this case, we want to cast the superclass to its subclass. This is called downcasting. It's not done automatically. To manifest that, we want to cast to this type. We must specify this type in the brackets. Let's cast it to the dog type. Now our variable dog1 has the method run. When we run the code, it works. When we are downcasting, that is casting to the subclass, we must be sure that the object isn't actually of the type to which we are casting. The program will return an error. If we do so, cat assign symbol, new cat. Now we are creating an animal and assigning it the value of our new cat. It means that we have done upcasting. It's performed automatically. There are no problems. Now let's create a dog and cast our variable animal to the dog type. As you can see, there is no error. The reason is that when we are downcasting, we must make sure the types are consistent. If we try to compile our program right now and run it, we will encounter an error. Class cast exception. The cat cannot be cast to the dog type. Let's delete this code. Now let's add the same method to the cats because they can run too. Create the method public void run. Print out the line, the cat is running. Go to the class main. Let's first delete all this code. Let's create 5 cats, 5 dogs. The task is as follows. We must use a loop and make each one of these animals run. How is this done? Let's create an array list. So what are we supposed to specify in the angular brackets now? If we write dog, we won't be able to add cats. And if we specify cat, dogs will not be added. We can specify the animal type, but this animal class is missing the method run, so we will not be able to make the animals run. One of the options is to add the method run to the animal, but then the birds will be able to run too. It's okay for them to run, But a running fish might be weird. There is another option. We can create a class which will inherit from the class animal, and it will be called running animals. But there is a problem. What if an animal, for example a bird, can both run and fly? Then we would have to add one more class, flying animals, and inherit the bird from both of these classes. This is something Java does not allow us to do. There can be no more inheritance than from one class. The interfaces were designed specifically for this. An interface determines what an object can do. As such, it's an abstract class without fields, but with methods. Let's create an interface. Select the menu item, New Java Class. The interface will determine who can run. Let's call it CanRun. Instead of the word class, write interface. We will specify in the interface what is to be done by the one who can run. It must define the method run. This method will not return anything, so it's void, and it will not have any parameters. Write void run, and in the implementation is not needed. We must only describe what the object can do. The access modifier public may not be specified, as it is set in the interface automatically. Now everyone who can run must implement this interface. To implement it, the keyword implements is used. Let's write it for the cat and the dog. Write implements can run. Do the same for the cat. And for the bird too, let it run. And here is an error, because the method run is not implemented for the bird. It means the bird cannot run yet. Press Ctrl+I and select the method we must implement, this method, and define in it what this animal will do. We will print out the bird is running. Now go to the class main, and as an array specify can run. And create this array for all the animals who can run. Call it animals too. Write assign symbol, new array list. And we can easily add dogs, cats, and birds to the animals. And no errors occur. Let's try to add a fish. Remember that the fish can't run. Add it to the array. And here is an error. Since the fish cannot run and does not implement the interface can run, remove it. Add some more animals. Dog 2, dog 3, and that's enough. Now let's use a loop and make these animals run. Write for the type of the array, can run animal. The name of this variable can be whatever you like. But it must make sense because we're going to iterate an array of animals. I have called it animal in animals. And now we will call the method run from our animal. Run the program and we can see that the dog is running, the cat is running, the bird, the dog, and the dog. Everything works well. You can guess that if the dog is an animal, we can cast it to the animal type, and all the methods defined in the animal class will be available to it. It means that the method run will be invisible. Also, if the dog can run, that is, implements the interface can run, it can be cast to this type. We can create a dog. Let's delete all this code. Create a dog. Cast it to the can run type and do the upcasting. Now the method eat is not available to our dog, because this method is not defined in the can-run interface. To make this method available, downcasting must be performed, that is, manual casting to the subclass. We are assigning the value dog can run to our variable dog. And our dog now has access to the method run and eat. There's one thing to note about interfaces. We will create one more interface able to fly. I will define it as an interface right here. Select the interface type and write able to fly. We will define the only method fly, which will return nothing and will not accept any parameters. The only one of our animals who is able to fly is the bird. Let's implement this ability. In Java, we cannot inherit from two classes, but there can be as many interfaces as needed. They must be listed and separated by commas. Write comma, able to fly. We encounter an error because we have not implemented the method fly. Press Ctrl+I and select the method we need. Click OK. And in the method fly, we will print out the bird is flying. Open the method main. Let's create a new able to fly object. The only one animal who implements this interface is the bird, so we will write new bird. We can call this method able to fly.fly. Run the program and you can see the line the bird is flying. It's enough for today. To review the material, please do homework. You must create the class employee. It will have one field name, a constructor to initialize this field, a getter for this field, and the method voice, which will print out the name of an employee. Then create three classes which are derived from the employee, programmer, driver, and cook. The constructors of these classes must also accept only one parameter, name. Then three interfaces must be created: able to program, able to cook, and able to drive. Each of them will have one method which does not return any data or accept any parameters. The names of this method must be program, cook, and drive. Each employee must implement a corresponding interface. Create three employees of each profession. Roll the call using a loop. That is, call the method voice from each one of them, and then make them all work. You will need 3 more loops. Good luck and see you in our next lesson.